Hello students, welcome back to the channel. In the last video, we have seen a few examples. We have actually studied the error analysis part, and then we have seen 1-2 examples. In this video, we will see a few more examples, and then we will go for the next part. Okay, so let us see here. The last example was this, where we had Z, which was related to different physical quantities A, B, C, and D by following relations. Then the percentage error in A, B, C, D was given, and we have found the percentage error in Z. Okay. Now, the next one we have, next question we'll see, slightly different type. So this will be the third question. Here they have given the resistance R is equal to V by I, where V is 100 plus or minus 5 volt should be the unit. Okay, so basically the true value is 100 and the error value is 5, and current is 10 plus or minus 0.2. So the true value of current is 10 and the error value is 0.2. So in this case we need to find the percentage error in R. Now how we do this is, again this is a simple application of the combination of error part. So R is equal to V by I, right? So we can write this as delta R by R will be equal to delta V by V plus delta I by I. Okay. Now this is the relation for relative error. Now for percentage error, what we can do is we can multiply both side by 100. So delta R by R into 100 will be equal to delta V by V into 100 plus delta I by I into 100. Okay. So what is happening here? Percentage error in resistance will be percentage error in voltage plus percentage error in current. So this is for maximum possible error. So in maximum possible error, we take everything as positive. So now delta R by R into 100 will be equal to, now delta V by V. So delta V is 5. Okay, delta V they are given as 5 and V is 100. So 5 by 100 into 100 plus delta I by I. So delta I is 0.2 by 10 into 100. Okay. So how much will this become? This 100 will get cancelled. This will become 10. So 5 plus 2. So that will come out as 7%. Okay. So the percentage error in resistance will be 7%. Fine. So the answer for this question becomes 7%. Now let us see the next question. I hope this is clear. Now, this is a different kind of question. Fourth question perhaps. So we have seen that earlier the relation that we have seen between errors, that is valid when the individual errors are less than 5%. Okay. Now in the cases where the individual error is more than 5%, how to deal with those cases we will see in this particular question. Okay, so let us see. Here they have given, if the error in the measurement of momentum of a particle is 10%. Okay, so the error in the measurement of momentum of particle is 10%, which is obviously greater than 5%, and mass is known exactly. Mass is known exactly means there is no error in the measurement of mass. We error is 0. Okay, the permissible error in the determination of kinetic energy is, they are asking us to find the permissible error, or simply the error in the determination of kinetic energy. Now what we have to do here is we have to relate kinetic energy with momentum and mass, and then based on that we have to figure out. Now kinetic energy formula is half mv square. Okay, the formula for kinetic energy is half mv square. Okay, now if you multiply and divide this with m, it will become m into v whole square divided by 2 times m. Okay, so here I have multiplied and divided with m. Now m into v is nothing but the momentum, so kinetic energy will become p square by 2m. Okay, so this becomes the relation between kinetic energy, momentum and mass. Okay, now so the true value is p square by 2m. Now if we see with the error, how much will be the kinetic energy with the error, then for that we need to find the momentum, the new value of momentum with the error. So the error in the measurement of momentum is 10%. So P dash will be the true value plus 10%. So P plus 10% of P. So that will become P plus 0.1 times P. So the P dash, the new momentum will be 1.1 times the true value. Okay. Now the kinetic energy with the error K dash will be P dash square P dash square by 2m. Now how much is P dash value? P dash is 1.1 times P. So 1.1 times P whole square by 2m. Fine. So K dash will be 1.21 times P square by 2m. Okay. A square is not required. So this is K dash and this is Ke. Now we can find the percentage error. The percentage error in the measurement of kinetic energy, that will be delta Ke by Ke into 100. Okay, so delta Ke will be the error value K dash minus the true value divided by true value into 100. Fine. So K dash is 1.21 times P square by 2m minus P square by, or we can simply write it here that ke dash will be 1.21 times ke. Okay, this way also we can simplify. It will save us few lines, you can say. Okay, so this will become 1.21 times ke minus ke by ke into 100. Okay, so ke will get cancelled. 1.21 minus 1 will be 0.21 into 100. So that will come out as 21%. Okay, so this will be the answer. The answer will be 21%. Okay, so if the error values are more than 5%, then this is the way you have to deal with it. You have to find the true value, then the error value, then find the difference by true value into 100. That will give you the percentage error. Fine. Now we'll go for the next part, right? Next we have one more type of question like this. Fine. So this a similar kind of question may also come in terms of resistance, because there also the relation is similar. Okay, so whatever concept will be applied here, same concept will be applied for resistors in parallel. Like there also we have a similar relation. 1 by R effective is 1 by R1 plus 1 by R2. So whatever relation is valid for this particular question, same relation will be valid for parallel combination of resistors as well. Okay, now let us see. Here we have the mirror formula, which is 1 by F is equal to 1 by V plus 1 by U. Okay, so the question is, mirror formula 1 by F equal to 1 by V plus 1 by U is used to measure the focal length of a given mirror. What is the percentage error in the measurement of F? Okay, so what we can do here is, this we cannot use the combination of error formula that we have directly here. So we have to go by the basics. We basically need to find a relation between small change in F, small change in V, and small change in U. Okay, so we can write this thing as F to the power minus 1 will be equal to V to the power minus 1 plus U to the power minus 1. Okay, now what we need to do is, we need to differentiate both sides with respect to time. Okay, so if we differentiate both sides with respect to time, we have to apply chain rule. So for F to the power minus 1, if we use x to the power n formula, whose differentiation is nx to the power n minus 1, so it will become minus f to the power minus 2, or I can write minus 1 by f square into df by dt. Let us suppose I have differentiated with respect to time or something. Similarly, on the right side we'll get minus 1 by v square into dv by dt. I hope you are following. Next we will get minus 1 by u square into du by dt. Okay, now here dt will get cancelled everywhere, and if we cancel out the negative as well, we will get the relation df by f square will be equal to dv by v square plus du by u square. Okay. Now if you see df, dv and du are basically small changes in f, v and u respectively. So what can be done here is we can roughly or approximately write this relation as delta f by f square will be equal to delta v by v square plus delta u by u square. Okay, so this becomes the relation delta f by f square is delta v by v square plus delta u by u square. Now here what we need is the percentage error in f. So for that we need to figure out the relative error. Relative error, that is delta f by f, will be equal to delta v by v square plus delta u by u square into 100. Okay, no, not into 100 as of now, into f. F will come into the multiplication, sorry. So this is an expression for relative error. Now for percentage error we need to multiply both side by 100. So the percentage error in f, that is delta f by f into 100, will be equal to f into delta v by v square plus delta u by u square into 100. Fine. So this becomes the relation. Okay. So if we zoom out, so we can see the answer will be the third option. Okay. Fine. Okay, students. So actually, we will end this session here. So in this video, we have seen few more examples on combination of error. In the next video, we will see significant figures concept. So we will be seeing how to apply the concepts of significant figures in addition, subtraction, multiplication, as well as division. Okay, so I will end this video here. We will continue with significant figures in the next video. Okay, fine. So I'll end this session now. Bye bye.